Uh, Hey everyone. So today we are trying to look at second program. We have done this thing in the lab, but I thought let it be there online so that you can you know try things or what I wanted to say. Let me just say it here at once. Okay. So the program is basically the basic operations on arrays and matrices. What I've done is I have made it into two smaller chunks. One is on an array. So when I say arrays, I want you to appreciate what MATLAB does. So that first you do it on your notebook, understand how complicated, how difficult the task is, and how MATLAB makes your life very simple. Whenever the sample size is very large. Okay. Hmm. So let us uh, start. Okay. So you can see I have written all the codes here. So one thing, let me just, the first thing, very first thing, whatever you are supposed to do is clear the workspace. So I always suggest you all to, the first line, you see the workspace here, whole lot of nonsense is there. So let me just select it and evaluate so that your workspace is clean. Okay. Second thing, what you're supposed to do, make sure you are in the proper directory. Okay. You are in the proper folder. Okay. So let us, so yeah, so here I have written the comments, in case you are not able to follow. Okay. So programs on basic operations on arrays. What all things can we do with arrays? Okay. As I told you, they are simple basic operations, but you know the help will guide you with the rest of them. So whenever I say array here, I'm trying to manipulate only one dimensional arrays here. As I told you, array can be one dimensional, two dimensional, three dimensional, four dimensional, and so on. Matrices are usually two dimensional in nature, but we will keep it simple, because we want to do it in the class, regular class also. Some numerical we want to solve. Okay, so three dimensional makes it complicated. Two dimensional anyway we are going to observe in uh, matrices case. That's why. Yeah. Okay. So what we will do is, let us have two arrays of same sizes. Okay, let us have two array of same sizes, some 1 cross n maybe, and a third array as n cross 1. Okay, third array as n cross 1. So let me get started first. So here you can see I have used the command input, which lets me enter. Okay, it makes the program whole lot of interactive. You can see the moment I execute the command, it is asking me a line here, enter the array of suitable size. Whatever that I typed in the single inverted comma has been displayed here, and whatever I now type in square bracket will be directly assigned to the variable a. Let me get started. Okay, let me use a square bracket and let me type in some numbers here, 1 3 1. So I will use a 1 cross 5. Okay, that will be my first array, and then there is second array. Use square brackets with space to create an array. So now the second array. No, second array. So what we will do, okay, what will you, okay, so now let me have my second array here. What size shall I give? Okay, so I have asked you to enter another array with the same size as that of A, because you cannot add a 1 cross 5 array with a 1 cross 6 array. Array dimension mismatch is going to occur. Okay. So dimensions are a very tricky thing whenever you want to add, you want to multiply. Okay, there's so many issues that are going to come into picture. Okay, now let me add a second array. As I told you, this array B also I want it to be of same size, otherwise I may end up having some errors maybe. Then I'm asking you guys to enter one third array, but this array I want to be of size 5 cross 1. Okay, so all these arrays with a space separator where a 1 cross 5. Now what I'll do for this particular third case, I will use a 1 semicolon 4 semicolon 2 semicolon 1 semicolon 5. Okay, now this makes it a 5 cross 1 array. You can see here in the workspace 1 cross 5, 1 cross 5, and 5 cross 1 for a C. Okay. See, uh, hmm. So the some fun commands that you can always use is, size, variable size, and you give variable, you get the value. Suppose I want to know what is the size of C, I will simply type in size in bracket, then I type in a C, a capital C, right? Sorry, capital C. You can see 5 cross 1. If it, I'll give it A. Okay, to get array dimensions. Okay. Okay. So what all operations can we do here, by the way? So I can add an array. So I know what is a A. A is a 1, 3, 2, 1, 2. If at all I do a 5 plus A, all the values will be simply added with the 5. You can see here 6, 8, 7, 6, 7. You can see A added with the 5. That's possible. You can say raised to the power 2. Now, shall I try this thing by removing this, what do I say? This dot here? Shall I? Shall I? Okay. So let me try this. Say to the power. So here the shift 6. Okay. Square. Okay. You can see here. What did I do? I tried the power, but without the dot operator. You cannot raise an entire matrix. What you can do is individual element of the matrix. You can raise them to the power. That is why adding a dot makes a whole difference. Even MATLAB is suggesting. Okay. Even MATLAB is suggesting that. Okay. Otherwise, maybe the matrix has to be a square matrix, it seems. Okay, you have to multiply a matrix with matrix, then the dimensions will agree. Otherwise, a 1 cross 5 cannot be multiplied with a 1 cross 5. You are going to get error. That is why adding a dot operates the same power with individual elements. Now this is fine. Now let us execute this. Okay. Okay. So here we are. 1 square, 3 square, 2 square, 1 square, and 2 square. That is possible. Then adding the single inverted comma is actually the transpose. If A is a 1 cross 5, A transpose is a 5 cross 1 matrix. Okay, you can see it's a 5 cross 1 matrix. Here, can you see it? Okay. Then what else can you do? 5 cross 1. Then you can see you can multiply individual elements. That's fine. 3 dot multiply by A. You can write a 3 multiply A, but sometimes you may get an error. Then what you can concatenate matrices. You simply write them besides the size should match. You can see here adding a and B. Simply appended this B in front of A. Okay. Whereas me doing so in a square bracket, but with a semicolon, they here you can see here they have been appended one below the other. You can see this is A and this is B. Now dimensions are 2 cross 5. Okay, dimension is you can see here 2 cross 5. Okay, you can add arrays given that their sizes match. Okay, given that their sizes match. Okay, so you can see A plus B. This is possible. Okay, given that both are 1 cross 5 matrices. This is something strange. You can do this one also. A 1 cross 5 with a 5 cross 1 is possible, and the individual element being added. Okay, this is very rarely used. I don't know. I cannot convincingly tell you now why it is used. You can bias it. We have done this thing, right? 5 plus A here also we have done this thing. What other things can we do, by the way? We can take the differences. We can multiply. Okay, you can see there are two types of multiplication. One is A multiplied by C, then this A multiplied by B. Can I try A multiplied by B? Shall I try it here? A multiplied by B. 1 cross 5 multiplied by 1 cross 5 is not possible. But you may want to multiply individual element by element. I want to multiply the first element of A with first element of B, second element of A with second element of B, third element of A with third element of B. If at all I want to do that, that's fine. So what I have to do is I have to put a dot here. You can see I have to put a dot multiply is going to solve the issue. Now this is fine. Okay, individual elements multiplied. Okay. Matrix multiplication is possible for this case. You can see here A is a 1 cross 5, C is a 5 cross 1. So if at all I do this, you will get 22. Okay, this is possible. Okay, C cross 1 is also possible. Is a C cross 1 possible? C is 5 cross 1, A is 1 cross 5. Yeah, C multiplied by A is also possible, and the expected answer is going to be a 5 cross 5 matrix. There you see. Okay. So this is one. Then the other is matrix operations. Okay. So here you can see the different matrix operations. Let me go to the matrix operations here. Mm, basic array operations, basic matrix operations. Wait a second. So here we are. So here you can see these are the programs on basic operation on matrices. So matrices, as we mean, usually are two-dimensional arrays. Two cross three, three cross four, or four cross four. Square matrices are of special interest because usually we encounter situation where we solve, you know, linear equations containing two variables, three variables. You want to solve a two-variable linear equation, you need to have two equations. So it's going to be 2 cross 2 matrix. Three equations, three unknown variables. You need at least three equations. That means it's a 3 cross 3. Okay. So usually it is a square matrices and sometimes other matrices. Okay. So let us try this. So the difference between array and matrix, I hope it is clear. Okay. So here let us start with having a square matrix only. Okay. Let us start with the some square matrix. Okay. Yeah, here. So what I have to do? I have to use the square bracket. Okay. There we go. I create a matrix 1, 3, 2, 4, 3, 5, 2, 2, 1, and array is individual element. This is a dot to the power 2. You can see this is dot to the power 2. Individual element have been raised by power 2. You can 1 square, 3 square, 2 square, 4 square, 3 square, 5 square, and so on. Whereas if at all I do a simple, if at all I remove this dot, shall we see what's going to happen if at all I remove this dot? Wait a second, let me try. See, I removed the dot here and to the power. Now what's going to happen? Remember, it's a square matrix. So you can multiply A with A. It's a normal matrix multiplication. 1 multiplied by 1, 9 multiplied by 16, 4 multiplied by 4. Is that the way it works? Is that the way it works? No, 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 no. Yes. 1 multiplied by 1, 9 multiplied by first row, first column, second column, third row. Okay, the third one. And okay, that's how it usually works. Okay. So, what other things can we do here? Okay. A to the power 2 is possible. Now, this is A multiplied by A, where you can see here, this is the answer 1 multiplied by 1, 3 multiplied by 4, plus 2 multiplied by 2, that is 17. 1 multiplied by, okay, first column, first to second, first to third, second, first, second, okay, that's how it works. Here will raise individual a component by 3. Now, did you get the problem here? If at all I have a square matrix of size n cross n, I can have a simply to the power 2 also, where A simply multiplies with A. Whereas if at all I have a 3 cross 2 matrix, I cannot do the operation simple A to the power 2, which is A multiplied by A, because you cannot multiply a 2 cross 3 with a 2 cross 3. Okay. So that is why a square matrix comes with its own advantages. Okay. But one thing is, the thing is what you want to do. Okay. That is more important rather than what does the operator do. You should have a clarity about what exactly you want to do. Okay. Now let us see the other operators. You can say single inverted comma. That's a transpose of the matrix. Okay, row replaced by columns, column replaced by no. And you can see how cool is this. With a click of a button, you can find determinant. Okay, determinants are very tricky thing. Okay, you have to take, so complicated. But here you can see determinant happens with a click of a button. It's not an issue for a 3 cross 3, but if at all you are in a 4 cross 4, 5 cross 5, imagine the pain. Okay, finding an adjoint also is very easy. You can see here for finding determinant, adjoint, or an inverse, you have to have a square matrix. Okay, you have to have a square matrix. You can see finding adjoint is also easy. Now that you can find a determinant and an adjoint, of course, inverse is also very easy. Okay, and you can do this kind of operation also. Did you see here? This one here is a backslash. It is not a it's a front slash, I guess, right? You can see this is fine. Okay, This was, let us see this. Yeah, it is dividing the values. Okay. This is fine. Now what we'll do, this is with square matrix. And this was the thing, the comforting, this is the comforting part, that you can have these three things with a click of a button. And you can see what is this operation, by the way. What is this operation? Inverse of a matrix can also be found by adjoint divided by the determinant. That's what we did here. And you can see both inverse of matrix I and A. Now this is the inverse directly using the command, and then inverse found using this particular formula. Both of them have worked and the answers are very, very similar. Okay, now what I'm trying to do is, now I'm trying to create two matrices. Okay, these were the operations that were performed on an individual matrix. Now we are trying to do, operate on two matrices. Now let me have another matrix B, which is of same size that of A. Then let me have two more matrices which are not a square matrices, some m cross n, maybe a 2 cross 3 or a 3 cross 2. Now let me go ahead and let us try this B, which is a 3 cross 3 matrix. Okay, because A is 3 cross 3. Okay, there you go. Created a matrix B. Then let me create a matrix C and a D. I will choose for the C. Okay. Did you see here? I am not using this particular run button. I am curious one. I'm in a learning phase. So I select individual lines and then I am executing. If at all you are in of a task where you are trying to loop and all those in big program, then you write entire program and run. We are currently in a learning phase. That's why we are doing these things line by line. Okay. Now let me give a 2 cross 3 matrix. Okay, there you go. Okay, this one matrix. So you can see here a 2 cross 3 matrix as shown in the workspace. Let me have a D also. Let me have a D also. Wait a second. I almost gave one. These two are sufficient. Okay. Now, can I add two matrices? Yes, given that the sizes match. Okay. Can I subtract matrices? Yes, given that the sizes match. You can see it in the answer. Now, can I do this particular thing? A and a C. Can I add an A and a C? Oh no, because A is a 3 cross 3, C is a 2 cross 3. You cannot do. Can I concatenate A and B? Yes, I think I can, right? Side by side, dimension should match. Can I concatenate A and C? A is a 3 cross 3, C is a 3 cross 2. I think they can be concatenated one below the sequence. See, this is A, whereas this is C. This is fine, but they cannot be, added sideways. They cannot be concatenated sideways. As you can see here, if at all I try this particular thing, I'm going to get a error. Okay, I'm going to get an error. No. Random scaling operations, these are fine. This is possible. I'm scaling A by 3, B by 2, some sort of superposition. This is fine. Then I can do a minus, that is a sign change. This is a possibility. Then anything interesting? Multiplication, the tricky part is there is some scalar and a vector multiplication. You see here, A multiplied by B, I get this particular answer, whereas A dot multiplied by B, this is an element by element multiplication, whereas the first one is a matrix multiplication. I want you guys to understand the difference between a scalar and a vector multiplication. The scalar multiplication is a dot and a vector multiplication. Oh, we got an error here. A and a C, we got an error because A was a 3 cross 3. C, by the way, was a 2 cross 3. Okay, there we got an error. Now, what about this one? C and a D, can we do? C is also 2 cross 3. D is also 2 cross 3. No, no, no. This is also not possible. But you can have a C multiplied by D transpose because C is a 2 cross 3. D transpose is a 3 cross 2. That's possible. Okay. So these are some. Okay. So what I want you to do is before you go to next program, so matrix dimension errors are usually the frequent ones which we encounter. That's why. So I'll take some numerical examples, work it on a notebook, then go to PC, run these commands, and find out whether you did was correct or not. Okay. That's it in this particular video.